Okay, everybody, thank you for joining me on this Saturday. As you could probably tell, for me in the UK, it's a glorious sunny morning. We don't get many of those in the UK. Certainly not early March, end of February. Yeah, I have to also pinch myself. It's the 1st of March today. When did that happen? So we are here, as the title slide suggests, to fast track your Lakehouse build with a metadata framework. Hopefully you're in the right session. And as you probably gathered, my name is Paul Andrew. I'm now the co-founder and director of a small UK-based data and AI consultancy. I've appointed myself the CTO, which will basically indicate to you all the grey hairs on my head, if you can kind of see that amongst the shadows that we have from the sunshine. I can date myself in my career by SQL Server 2000. So if anybody's used SQL 2000 or beyond, that's kind of where my career started in data, working in the NHS in the public sector, helping them do things with their databases. I also tell my children I'm older than Google, which is confusing to them because they can't possibly conceive a world without Google. It would seem. I tell them that I know what a dial-up modem sounds like, and I also tell them that the first car I drove had a manual choke on it as well. Ultimately, for you, this means that I've been designing and delivering data platform solutions for 20 so years now. So I've got all the battle scars, and I've been through all of the pain, and I now get to do this day to day as a consultant. But hey, if your job is your hobby, then you never work a day, right? And ultimately, for me, the very best part of my job now is doing things exactly like this. It's going around to events, it's speaking, it's sharing that knowledge. And for me, that's the very best part of my job now. Solving those problems and presenting it, sharing that knowledge with you guys. So a couple of slides then to just set context for today's session, and starting with that problem. And to kind of frame that problem, what I'm going to do is let's just kind of pick apart my session title here a little bit to kind of give you some information, some context about what I was thinking when I kind of came up with this. So fast track, it's kind of a Microsoft term that you might have encountered with some of their other kind of offerings of fast track you to Azure and fast track this, etc., etc. So I kind of played on that because people have kind of seen that from the Microsoft marketing. But ultimately, for me, that problem and that challenge that I want us to address this morning is really just to simplify that Lakehouse build. And as you can probably tell from the rest of the title, the way we're going to try and simplify it is with a metadata framework. In terms of our Lakehouse, I think, again, just for context, as I say, I've been doing this for quite a long time now. What do we mean by that Lakehouse that we want to create? Well, if we kind of look back in time a little bit and how things have evolved, the problem of what we're trying to do hasn't really changed for me. And that problem is getting that insight from our data. We have some data sources. We want to unlock the value in it. We want to make informed decisions from that data. That problem hasn't changed. But what, of course, has changed is the technology that we use to do that, the technology we use to apply that and get that insight, and the tools we implement. So once upon a time, we might have had an OLTP database or application database. We might have done something that we called extract, transform, and load. I think it's still okay to call it that. And we might have used a data warehouse as the big box in the middle to get from that source to that insight. And as mentioned, when my career started, that was kind of very much the intent of what we were doing. We were very much in an on-premises world of SQL Server, amongst other tools. Now, of course, that's evolved, and that picture has evolved to probably something a little bit more like this, where we now describe things as a lake house or a data ware lake, beach house lake, or some other combination. I really don't mind, but the problem hasn't changed. The technology, though, when we think about that picture at the top, the boxes, really when we think about that middle part, we're probably not describing it as a data warehouse anymore. I think it's okay to, but probably not. Bill Inman might have a problem with that. But really, if we're just thinking about that technology now in the cloud, we're just decoupling those resources. We just want to do something different, which means that we can then scale in most cases, scaling the storage, scaling the compute. And if we think about what Databricks gave us with Delta Lake, that ACID transactional resilience now over our data lake storage, which makes it possible for things like Spark to come in amongst other compute resources now to actually distribute those queries across that storage as well and get us to where we need to be. Are we still doing extract, transform, and load? To be debated. Do we need to change the order of these words and include other things? Sure, if you like. I'm not precious here. The goal, of course, as I said, it hasn't changed, but that's where we want to get to. Now, considering that cloud technology and different ways we could implement it, as mentioned, to kind of set the context and kind of frame the problem for us in this session, what I'm saying to you is that we want to simplify. Fast track, sure. Simplify, yeah, absolutely. So we want to simplify this Lakehouse build. We want to simplify that journey of extract, transform, and load, if we're calling it that. And we want to simplify how we actually then consume that data to gain insight from it. So the goal and the problem is set. That's what we want to do. Now, the solution that I want to present to you, or at least one solution, or at least a solution that I've been working on now for a while, is what I'll describe to you as Cumulus. Cumulus is a product that is open source, fundamentally. I'm not here to sell you anything. I'm here to solve technical problems with you. And I've wrapped up this solution for you in a product that we call Cumulus. It's on GitHub. You can go and use it. And everything about Cumulus is metadata driven. Now, there's some bullet points and things in here. Don't really like bullet points in slides. I like pictures. So to kind of tell you a little bit more about it and also just a little bit of history, if you might have seen me present and things in the past, what you might be aware of is a framework that I put out there in the wild a good few years ago now that I called the PROC framework. So the PROC framework, it was an open source control mechanism to orchestrate all of your pipelines in Azure using Data Factory in the beginning, and then that evolved into Synapse Analytics as well. So just to kind of put this in context on a timeline here, when I say to you, we now have this thing called Cumulus. Cumulus is now based on that older PROC framework that I put out there in the wild a long time ago. It is still in my own GitHub repository. You can still look at it and use it. There's still some documentation there. The problem though with that PROC framework is the Functions app, it was created using .NET Core 3.1, which as you might be aware is no longer supported. So it meant that it was time for an upgrade. It was time for a shift. So what I did was, in starting CloudFormations as a company, my intent was, of course, to bring that PROC framework in-house and also extend it and enhance it to simplify that journey and that problem that we're trying to solve. So as you can see in this picture, that PROC framework now forms what we would call the control component of Cumulus. Cumulus being the piece here that's scoped in that grey box to get us from the left to the right. So taking that as a bit of a architecture slide here, fairly generic icons, obviously quite deliberately, but when we think about Cumulus and we want to simplify that journey, what I'm saying to you is that we have a module that will support that ingest to get the data from the source into our Lakehouse in that raw state, or a bronze state if you prefer. Bronze, silver, gold, raw, cleansed, curated. I don't mind interchangeable labels here. I think bronze, silver, and gold is obviously very good for business users. They know that gold is better than silver, so that's what they go for. For us as data engineers, I prefer raw, cleansed, and curated. But we get that data in, we use ingest to do that, and then we use our transform module to do the same thing. and control sits there to look after that dependency chain, to handle the executions, to get everything where we need it to be as part of that end-to-end process. So that's the intent of simplifying, and this is one way that we do it. Now, this is an architecture picture, I appreciate. Let's kind of peel it back a little bit and think about the technology for a moment. Again, fairly generic, kind of quite deliberately, but what we have within this logical kind of view of the architecture of Cumulus is we have our data lake storage, of course. We have some Spark compute. Again, how we implement Spark to be decided. We have some orchestration pipelines, and we have metadata. So as you probably saw in the previous slide, everything here is metadata driven. And we want it to be metadata driven because that's what's going to help us simplify that journey. So everything metadata driven in an Azure SQL database, and then just to kind of support that orchestration with some Bootstrap pipelines, we have some Azure functions as well that can kind of help us out get there. And get there from the producers, the data sources, to the consumers with that data insight. And then what we do in the middle is up to us. Now, of course, the reason for this is to kind of really underline that point of this is open source based on the MIT license. It's open source, and for us, it's very much about playing to that open source, ecosystem and those open standards. So for us, thinking about the open standards of Delta Lake as a storage structure and format to organize our data lake. Spark as an open source compute engine, obviously in the beginning, implemented in lots of different ways by different vendors, but open standards and open source is very much what we want and where we want to be, which means that, you know, on a longer timeline here, we're not worried about lock-in and things like that. We have everything that we need to kind of get going. Thinking about that though, and thinking about this picture, what do we actually then do when it comes to implementing it? And we're playing to open standards and obviously open source quite deliberately, which means that we can then be quite flexible. Flexible in terms of what we actually deploy if we wanted to use Cumulus. So we could deploy it using Azure Synapse Analytics. Obviously, probably not the best choice anymore, considering the Microsoft product roadmap and things, but we could do what I would call a partly decoupled architecture. Partly decoupled, you know, because the compute, the orchestration sits within the Synapse workspace. We still have the data lake storage kind of separate. So we could implement Cumulus using Synapse. We could, and at some point soon will, be able to implement Cumulus using Microsoft Fabric. It's not quite there yet. We're still kind of working out some details around the Fabric APIs and how we do things dynamically, because everything in Fabric wants GUIDs to call it dynamically, which then means context within workspaces becomes an issue. And yeah, there's a few kind of wrinkles that we just need to iron out there. But at some point soon, we will be able to implement Cumulus as part of a Fabric environment, which we could argue as a fully coupled architecture. Everything's in there. It's in our one lake storage. We've got now our SQL database that can be implemented as part of a Fabric workspace as an item, as you probably know. Still in preview, mixed reviews, but you know, it's getting there. And we could, and probably most likely today, it's a bit of a moving target, but today we would probably want to implement Cumulus using a slightly more decoupled architecture, using, for me, the mature products and the favorite products, I think, at the moment of Data Factory, Databricks, Data Lake. All things starting with data, it means we're in a good place. So that's what we're going to look at today, implementing it using these three, four more mature products, but at some point soon, we will be able to do it in Fabric. We can do it in Synapse as well. So let's think about that problem statement then, and what I said to you about simplification. Now, I'll also make kind of two further arguments here about that simplification. The first one being simplifying that Lakehouse implementation, as I've said, through that metadata. Now, depending on what the layers of your stories look like, depending on what you need to do to get your data from your producer to your consumer, there's still going to be some engineering work that's required there, some business logic that you want to apply, almost certainly. But we can simplify that journey with Cumulus and with some metadata represented as SQL. And for me, obviously, this is where my career began with SQL, not with Python, not with Scala, not with any of these other things now that they teach in academia, but for me, it was SQL. So when I think about simplifying that journey through that metadata, if we kind of oversimplified it a little more, within that metadata database, as I'll show you, we have ingest data sets, we have transform data sets, and we have control pipelines. And we can get from left to right here potentially by only writing SQL. We've got lots of boilerplate code in Databricks and in Python and in notebooks, all kind of wrapped up, driven from that metadata, which means that we can get from left to right quite easily. And I'll show you this, assuming the demo gods are in my favor. That argument of simplification, though, doesn't necessarily just end there with that kind of left to right. Because for me, there was kind of a secondary goal here when it came to simplification in this platform, when it came to more the DevOps side, the platform plumbing, if you like. Data plumbing, sure, we can simplify that with metadata. We could also simplify probably a little bit of that DevOps story as well. So to kind of frame it a little, if you might have seen this horrific picture that I drew a while ago of a very distributed and multinational set of orchestration pipelines for a customer. And we managed all of this using that Cumulus control and that earlier proc framework. My point, though, being is that through that metadata, we can also simplify our deployments. So if we think about everything that has to go into that to make that possible, how small can we actually make each deployment of what we need to do in that platform? For me, if we look at a simple journey of developer and feature branch and actually what's going into that feature branch at each time of deployment, for me, I like to say to them, well, if it becomes a pipeline or a notebook or something else, let's try and package that up. So for a pipeline or a workspace, not a workspace, a link service or a data set or a trigger, let's package that up so we only have the artifacts we need as part of that deployment and use that metadata to put that pipeline into that control table, new pipeline, new row in the control table. And ultimately, once that's done, and quite importantly, setting that enabled flag for that pipeline to 0. So it's not enabled as part of this wider ecosystem at this point. We can do some testing on it. Once we're happy, we can then enable it through that metadata, and then it can be used as part of that wider solution. So simplifying that deployment through metadata, if we kind of put it in context of what it might look like for us with some environments, what we do in development, we maybe do some testing, we maybe have a pre-production environment for some performance testing, some integration testing, whatever you might want, and then obviously all the way through to production as well. But because we've got that metadata support, what it means is that we can go through each of those stages in a fairly low risk way. Because we can deploy a new pipeline, a new artifact, we can do an integration test on it in place, almost like a soft deployment, if you like, into production. Nothing is really going to affect the rest of the production environment because it's not enabled in the metadata. Of course, once we've been through all of those boundaries, we're happy, we can sign off, we can enable it, and we can repeat. So my second kind of sub-argument to you there is that through metadata, we can not only simplify that data plumbing, we can also simplify that deployment and that journey, because we can use that metadata to actually control what's running in each of those downstream environments. And I've done this, it works quite well, it's nice. So that's kind of enough slides, I think, for this one. Let's actually kind of switch over and actually get into it, because there's a lot to cover. I want to show you most of it. I want you to get hands-on with most of it as well. So let me ditch the slides and change screens for you. So the place to start is with a repository. The repository that I've said to you, it's publicly available. I'll put a link in the chat for you. It's there. You can start working with it. Once you've got that repository, cloned, copied, open, however you prefer, I might go to the workspace file. That means that we can then open that up in VS Code, if you prefer, Visual Studio or VS Code. I think there's an ongoing debate there. But we might open that up in VS Code, and then the first thing I might do if I was working with this is use some bicep. We like to use our biceps to be strong. Bicep's kind of fairly new to me, but it's good, it works. Bicep versus ARM templates versus Terraform. Again, I really don't care, but we've got some bicep in here for Cumulus to help you out. One thing that I do like about bicep is that we can now right click and we have this thing called the bicep visualizer. A bicep visualizer that will give you this very, very pretty picture of all the things that that bicep script is actually doing. Is this useful? I'm not really sure, but does it look very pretty? Yeah, absolutely. And we like pretty things, right? So, hey, bicep visualizer, good. So really, just to make the point, there's lots of things happening in this bicep file. The bicep file built on a whole bunch of modules to get you where you want to be, to get Cumulus deployed using that more mature offering as I kind of described to you. So to prove there's no cheating here, this is a live demo. We don't record things, recordings for chickens. Now demo gods are just going to come and bite me the whole way for the rest of this. So I have in my Azure portal a pay-as-you-go subscription with no resource groups, completely empty. And what I might do is go in here and deploy the bicep file, deploy our biceps. And it's going to ask me some information about what I want, my subscription, of course. Yes, I want UK South in my case. And yes, I'm going to use these parameters. Now, this takes, obviously, depending on what day it is and things, probably 5 to 10 minutes or so to run. It doesn't give us, oh, it's failed already. Okay, good. You see, what did I do to the demo gods? I had to poke them, didn't I? I'll see what it's failed on in a minute. This gives us probably 80-ish% of what we need for Cumulus to get it going. Actually, I'm going to guess why it might have failed. I'm going to change this identifier to a 6 in the naming conventions and just try that again. This will be a great start to the demo. So yeah, as I was saying, it will get us about 80% of the way there with deploying all the resources we need. There's still a little bit of configuration and a few tweaks and things that we need to iron out. But the goal here is very much to kind of get to a state where this single bicep file will give us everything we need to get Cumulus deployed, including the resources, the infrastructure, and also those code artifacts as well. Code artifacts that I'll kind of get onto in a minute with the different bits and pieces. So I'm going to leave that one running. Let's just probably do a little refresh in here. I'm kind of curious why that first one failed so quickly. And hey, live demos, so why not? Key Vault. Yeah, so it was the naming. So Key Vault has as you might be aware, a soft delete. And actually, I ran that 05 script earlier this morning, and then I deleted it. So obviously I'm kind of preparing for the demos now. And basically, yeah, I needed to just change that incrementer so it is deploying from a fresh instance. So yeah, it failed because that key vault, it was deleted, but it's in a soft delete state. So it means that I couldn't deploy the same one again. Hey, good to have failures, keeps it exciting, right? But you'll see now that 06 resource group is whirring away. I'll kind of give it a few kind of refreshers and things in here. I'll kind of leave that deploying. And as mentioned in my kind of intro, I'm quite old. So in what I'd say is true Blue Peter style, we're going to do, here's one I made earlier. Question, could you include date time to prevent the error in the future? Date time if you wanted, but probably only in the name of the key vault. So sure, you know, if you wanted to deploy a key vault with a naming convention that included a date time, then yeah, that could work. But this was really just about reusing the name of a key vault because that previously deleted key vault was still in the recycle bin, let's say. But yeah, potentially. So anyway, I'll leave that kind of 06 one there, and obviously for you guys, kind of that bicep, it's waiting to complete, but we'll move on. So here's what I made earlier. If I go to my dashboard, so I have a resource group already deployed with all the plumbing and the things that I need to get going. So where do we go next? Well, we could go into our data factory, we could go into Databricks, etc. But let's think about our data source firstly, the data source that we want. Now, for me, and hopefully you'll agree, the best data source to use is AdventureWorks. It's the only real data source. All these New York City taxi things and whatever else and worldwide exporters, we don't want any of that. We want AdventureWorks. We want bike paraphernalia. So I have an AdventureWorks database. Yeah, Northwind, definitely some Northwind as well. So I have an AdventureWorks database with all the usual good stuff in it of order headers and order details. Obviously not the largest data sets in the world, but demo friendly anyway. So I have my data source. It's sitting on an Azure SQL DB instance, as you can probably tell. I didn't call it AdventureWorks at the time, but it's an AdventureWorks database that we know and love. So what do we want to do next? Well, I think the next thing to do to kind of introduce you to Cumulus and the metadata that we need is to look at a database diagram. Yeah, why not? Because that database diagram will kind of help inform what metadata we need to put in here. So what I've got for you is a database diagram of all the things, all the tables, and we'll kind of go through this a little bit of a time, obviously not too slowly, kind of, and just keep an eye on the clock there. So if we firstly think about that journey, we've got our AdventureWorks database, we've got some infrastructure deployed, we need to put some metadata in here to get that data flowing. So what we do in Cumulus is we have a bunch of tables firstly related to the connection information. Connection information about the source that we want to work with. Where is it? What's it look like? What we're going to call it? What credentials are we going to use? Etc. Connection type information. You can obviously guess what's in there. And also potentially some compute as well. So once we get beyond that kind of ingestion journey, or if we need integration runtimes or other stuff, we can put some metadata in there as well. If I kind of move to the left and we think about that ingestion journey, quite simply, some data set metadata, some attribute metadata. And for things like an AdventureWorks database, or indeed any kind of ANSI SQL database, it's obviously very easy to kind of scrape and pull some of that metadata from that source system and actually get it to pre-populate some of the Cumulus tables in here. Kind of just something that we're working on as a bit of a sideline as well, just to kind of simplify and accelerate that journey. But for us today, we need to put some data sets in here, we need to put some attributes in here, and that's what we'll kind of focus on firstly. And I can kind of show you some things, and we can start off getting that data flowing. So in my connection types table, if we kind of just do a few selects on here, as you might expect, we've got information about, is it an Oracle database? Is it a SQL Server? Is it an Azure SQL database? Which, of course, today it absolutely is. So I'm then going to, with my other kind of query window, this is all I really need. I just want to put some connection information into that table to start getting this data flowing. I'll kind of show and describe this as we kind of go through for it to make sense. We need to kind of come at it from a few different directions to really kind of paint that overall picture. So we've got our new connection in here, which I'm just going to call AdventureWorks demo for now. And it's going to that logical SQL instance that I showed you. Connection name, etc., etc. So I've got that in place, and then we need some data sets. So data sets, in this case, could be just our sales order header table. So let's just go ahead and throw some metadata in for that. I'm also just going to grab that connection ID as part of that insert query. And then what that looks like in my datasets table, as you would probably expect, is a new one that I've just put in for this example. And there's a few things that we'll kind of call out in here in a moment when we actually then go and run this and see what it looks like. So got a connection, got some data sets. I just want to now put in some information about the attributes. So here's one I made earlier a little bit, but it's metadata, it's SQL, it's easy. So inserting into the attributes table, I'm just going to go ahead and grab that connection ID again, and also this time the dataset ID. So we've got that kind of relationship there between connection, dataset, attribute. All good. So now we've done that, I can pretty much get rid of that window. And we have in our attributes table a bunch of stuff. The bottom ones, of course, being what I just inserted. And you'll see that we have in here information about what's the primary key, quite important. What data types do we need? Now, because obviously we're going in this case from a SQL database into data lake storage and Parquet files, we need to do just a little bit of kind of data type massaging to kind of convert them as part of that execution. So we have some information about that, maybe some formatting on those date times if we need it, information about partitioning if we wanted to, and those kind of enabled flags that I alluded to at kind of every level in this metadata as well. So I've got all of those things in there now for that kind of first piece of ingestion. Let's turn our attention to Data Factory next. So in here, I have my Data Factory. I've got those Cumulus pipelines and things deployed. So if we look at ingest, and in this case, we want to ingest something from Microsoft SQL in this case. Now, quite deliberately, this is very generic, it's very boilerplate, because of course there's different flavors of SQL on premises, in Azure, etc., etc. Also, we might want to authenticate against those SQL instances in different ways, with SQL Auth, with a managed identity, with a service principal, etc., etc. So we've got our pipeline here that will do that, and what I'll show you in a minute is it's going to go and get what we'll call a payload from that metadata database. And we go through the motions with some of the variables and things to help us out kind of with troubleshooting a little bit as well. And then we have a switch activity. That switch activity just helps us to decide, well, is it a SQL DB and I'm going to use a managed identity to authenticate, which we will today, or SQL Auth or SQL Server. The reason for having these differences is that Data Factory creates different data sets and different link services depending on what you're doing, and it's those link service types and data set types that we can't actually avoid. We can't make them dynamic at runtime. So we have to have versions of each one, and then we can obviously decide at runtime which one we use. And that's the point of this switch activity, just for us to decide what we're going to work with. And the way we do that is simply by providing it from the metadata. And you might have seen in that metadata connections, we're providing a link service name. That link service name then just helping us decide which one of these in the switch activity we're going to run. In the case of today, it's a SQL DB, it's managed identities that we're going to authenticate with. So we have a copy activity that's going to do that work for me. So everything from that pipeline level is parameterized. Pipeline, it goes and gets information from the database, parameterizes the data sets, which in turn parameterizes the link services. So for that copy source, if I open the data set, it's passing down those parameters to what we need it to do. If I go ahead and edit the link service, you see and it's being passed right down to this level as well for, in this case, the host name, the database name. But for the different sources that we've currently got supported, obviously every kind of combination that you might want to work with, which means what I can then do is in here, if I wanted to actually start ingesting that data set information that I've put in, I can run this and it's going to ask me now for a dataset ID. So that dataset ID from my table, in this case, 12, didn't actually know. So I'm going to go and run that. And while that's kind of ticking away, I can kind of just show you roughly what it's doing. So there's a bunch of stored procedures in here that will go and get what we'll call a payload. So as you can expect, bringing together everything from that metadata to bring that data into my raw storage area. So in the spirit of no cheating, things are running. Let's jump into Azure Storage Explorer. I've not got my AdventureWorks demo folder in here yet in raw. It's just appeared. Now, what you'll see is it's created that folder for me for my sales order header table, version 1. And you'll notice it's got a full folder. So the taxonomy and the way we organize that data lake, it will support, of course, change data capture and incremental loads. But what we have in the metadata is on the datasets table, a load status. So over here, we've got a load type and a load status. The load type can be incremental or full, depending on your source. But then what we do is with this load status, we know that if it's an incremental load, but we haven't actually loaded it yet, so it's the first time we're doing it, it will obviously go and do a full load because it's that first time. Once it's done that for the first time, it will then start working with an incremental load, etc., beyond it. So at the moment, you see we've got a load status of 2. It was 0. It's now 2 because it's done that first full load. Assuming this is completed, it has. I'm actually just going to run it again. So I'm going to run it again, and in the Storage Explorer, you'll see now I've got my full. It's nicely partitioned by year, month, day, and actually hour in this case as well. So I've got my AdventureWorks data kind of flowing in. Because I've run it again, if I now just kind of refresh at this level impatiently, I always say the more times you hit refresh, the faster it will go. Not the case, of course. But if I kind of just check this datasets table again, let's just check the pipeline. Getting there. Faster Data Factory, faster. Updating that metadata. So I will now have an incremental folder in here as well. So as you probably saw in that datasets table, we have some information about how we want to capture those changes. Not necessarily perfect at this point, but we're just getting that data into that raw layer firstly from the source system. So if I refresh again here, you'll see we've now got a load status of 6. 6 representing the fact that we've done a full load. We're now doing incremental loads. We're using that load clause that's also in the metadata, in this case, where modified date is greater than get date minus 7 days. So we're always getting the last 7 days of data coming in. It's my AdventureWorks database. It's not changing, but we could do. So I've got that data into raw, and again, kind of Blue Peter style. Here's one I made earlier. So I've done this for what I've called an AdventureWorks database, not demo. I've got my 3 tables in, order headers, all in incremental loads. I've done this one a few times now. So different data coming in there, products, order details, etc. as well. So say with a few lines of metadata in that query that I closed, I've got data flowing in to that raw layer. The next thing we need to do is get it into a cleansed state. So the way we organize that raw layer is that it's just the new data coming in based on those changes, stored and partitioned just as Parquet data. We want to get that into a Delta Lake table. So to get it into a Delta Lake table, we have another pipeline in our data factory that we call merge. Doing a merge, we want to get all of that attribute information. We want to create a Delta Lake table, and we've got everything that we need to do that. A switch activity, again, just for authentication, depending on how we want to talk to that cluster. Are we going to use a job cluster or an interactive cluster in Databricks? For you to decide, controlled by the metadata as you prefer. So what we have, if I flip over to Databricks now, and we're thinking about that journey from raw to cleansed, we've got a whole bunch of notebooks in the repository to do that work, a bunch of utilities that will go and dynamically create that merge statement as part of that operation, also go and do things to set up that Delta Lake table, all boilerplate code, all there, all kind of ready to go. So what that means for us, if my Databricks cluster kind of wakes up, what I can do now in my data factory pipeline, if I actually just go and grab one of the dataset IDs of the ones that I ran before, let's just grab number 2. So I'm trading kind of just dataset IDs here. That's all we want. So dataset ID number 2, hitting that merge pipeline, excuse me, going to go and do its thing. I'll kind of impatiently hit refresh because I'm waiting for that cluster to wake up. But, you know, the journey of simplification here, it doesn't probably look that simple because I'm kind of clicking around and going through lots of things, but it's all boilerplate code, which hopefully now means that for you guys, it's simplified because we are just putting in that metadata. And, you know, our attributes and connection information, not a big deal. We can do that for AdventureWorks. This one, we've got stored procedures to go and get that merge payload. So trading dataset IDs, payloads pass to those very dynamic boilerplate pipelines. So in this case, my payload for dataset ID number 2, as you can see, information about the Databricks cluster, what it is we want, where it's going to go, getting data from raw into cleansed, and also as part of this payload, if I kind of keep scrolling, it's dealing with the column list, it's dealing with the data types, any formatting, it knows what the primary key is to support that merge behavior, it knows what the hierarchy of that folder structure is that, you know, we have in the storage. So all there, everything that we need. If I go back over here, oh, very impatient. Of course, the cluster is going to take longer to start up. I should have had a longer time to live on the cluster, probably my bad on that one. But I'm sure you will kind of get the idea with that once it gets going. And obviously my pipeline is now just waiting for that cluster to start. I'll give it a little longer and then I'm just going to move on because we don't really have time for waiting. Come on, Databricks, faster. If we play the here's one I made earlier game, perhaps while we wait, and I actually just have a look, at my catalog, which is also now taking longer to load. Oh, because you're waiting for the cluster as well. Yeah, fair enough. Let's look at it from the SQL editor, from the warehouse perspective. Let's cheat. Let's use that compute instead. So what we have here, here's one I made earlier. We've got those cleansed data sets kind of already coming in. So my order header details, my sales orders, my products, etc. So obviously with only a few lines of metadata, I've got from the source system into raw. I've also now got into cleansed, with a Delta Lake table that's now got change data capture information from source to raw. It's also got information about merging that data from raw to cleansed. Can't we try on serverless? Yeah, I did. So yeah, this is the serverless warehouse that I just used to kind of show you this from the catalog instead. So that's what's going to happen at the cluster started look. So that's what's going to happen, and that's what this pipeline is then going to go and run. If I kind of impatiently refresh in there as well, you get the idea. So the next thing then I want to do is probably apply my business logic. I want to get from that raw state into a curated state with cleansed data sets as well. So that's ran. Let's move on. I want to try and get to the end obviously here. Let's go a bit faster. So in my transform now, if I perhaps bring it back to the database diagram, similar sort of idea, but this time we're dealing with notebooks. Notebooks that want to understand information about our data set, our attributes again. So now we're thinking about obviously moving from that input-driven schema to an output-driven one. So data sets could be a fact sales table, a DIM product table, and I want information about that. And Cumulus will help us with that as well if we wanted to. Notebook metadata, what do I want to go and run? So cheating slightly, here's one I made earlier. So in my workspace, under there, in transform, I've got some unmanaged notebooks. So these unmanaged notebooks are very simple, doing what I said. I've got a date dimension, I've got a product dimension, not complicated. I just threw them together quickly so we could kind of get to the end here of what we might want to do. But at the moment, these were what we'll call unmanaged notebooks that Cumulus can just go and run as part of its orchestration. What we do also have is this idea of a managed notebook. And the difference being is that Cumulus can use that metadata in terms of the dataset and attributes to actually front load a lot of that work to create the inputs and also the outputs for when we're applying that business logic to do whatever it is we need to do to say, get to our fact table. And obviously for me, this was that point of simplifying through SQL. So what we can also do with managed notebooks is define a SQL statement as a string, and then actually just pass that SQL statement string to Cumulus as part of a managed notebook. And then that will use the attribute information to get us to where we need to be. Don't really have time to show you all of that today, but if you just kind of take my word for it that this is possible, and we can just then execute that SQL string and get to where we need to be. For now, I'm going to cheat though. I'm just going to turn my attention to our transform pipelines this time. I'm going to use a pipeline with a very similar pattern. It's going to get some information. It's going to go and run what we need from my metadata. In this case, my transform data sets. Let's pick on the fact table. Why not? Let me go and start a cluster. In this case, it's going to get another payload for this notebook. So dataset ID number 5, I think we're on. So I have a pipeline that could just go and run that. So just passing around dataset IDs again to then go and do that work. 10 minutes on the clock. Let's assume everything's perfect and everything runs successfully. So I've got, just to recap, source to raw, raw to cleanse with a merge, and then in my case, here's one I made earlier that's still running, from cleansed to curated to give me some facts and dimensions as well. I've obviously just ran it for one notebook and one data set as part of kind of showing you this, but of course we could now look at running it for all of them. If let's just turn our attention back here. So, here's what I made earlier. So in this curated database, I've got some dim dates, some dim products, some dim facts, and those have all been created using those kind of notebooks that I flashed up. So I've now got my ingest parts, I've got my transform parts. I obviously want to orchestrate everything. To orchestrate everything, we need Cumulus Control, or my older proc framework as it was called, albeit kind of updated and upgraded. If I give you a whistle-stop tour of that from a database perspective, we have at the bottom level pipelines. I want to go and run some pipelines, a bit like I have in debug mode. Pipelines that will have execution stages. Let's call it extract, transform, and load. Stages that can then have a batch, daily, hourly, weekly, as you prefer. So with that kind of hierarchy of things, I can then use some other pipelines to go and run everything that we need with some dependencies, with some pipeline parameters. In my case, the dataset IDs that I've been passing around to get through each of those layers. So with that, if I kind of keep scrolling here, I've obviously got some stuff kind of pre-configured in the metadata. So I've got a batch of daily. I've got some execution stages to go through each of those layers that I kind of described, and I've got my pipelines table. So that pipelines table, as you probably would expect from what I've shown you in Data Factory, I'm using that SQL ingestion pipeline. I'm using it 3 times though. I'm using it for 3 data sets. I'm just calling the same pipeline 3 times for what I need. The same with the merge. I'm just calling it 3 times. And then I've got a transform pipeline that's going to run for 3 notebooks, my date dimension, my fact table, my product dimension. So again, I'm just kind of reusing that boilerplate code in here in that pipelines table. The pipeline parameters, of course, for the pipeline IDs, as you would expect, and then just giving it the respective dataset IDs for what I then need to go and do. So I've got all of that in my control tables. What we can then do if we wanted to look at control, I say it's based on that earlier proc framework. So there's a lot more information out there as to how the plumbing and things work. But what that means for me in the Data Factory, if I go to this level, I've got what I call a batch executor. Batch executor will look after that end-to-end process. It will call my stages, which will go into that stage executor with those vertical boundaries of what I want to support that dependency chain. That stage executor will run in parallel. And at the lowest level, I've got a pipeline executor, which decouples the call between what I describe as the control pipelines, the bootstrap pipelines, and those workers. The workers in this case being ingest and transform. So we'll go through the motions here and go and do that. And you'll see that I'm calling out to some Azure functions to kind of make it possible to do that interconnection between, say, Data Factory and whatever we might want to work with. So what I'm going to do here is I'm just going to trigger this because we're running out of time on this session. But I'm going to go and trigger that. It's going to go through the motions in a second. Oops. And we can look at this now, again, from the metadata with an execution table, the current execution table, which I can impatiently kind of hit refresh on and things as well. What I'll show you while that's kind of just spinning up, just kind of briefly. So as part of that deployment, you'll notice there's some Azure functions. So those Azure functions kind of sit there to help us call and do things with those worker pipelines. So, if I wanted to, I've got a pipeline that will just go and do an execute. So if I'm using your favorite tools like Postman or something like that, I could go and pass in a body, subscription ID, resource group, what the orchestrator is, what pipelines we want, etc. I've got things in there here that will then go and validate, and we use Azure functions as that kind of handoff to separate that work a little bit. Azure functions that are now updated to .NET 8 that is in long-term support. So those functions kind of sit there as well, just for awareness. If I come back to my data factory, I go back to my monitoring, I can impatiently kind of obviously hit refresh. I can impatiently hit refresh in the current execution table. But as you probably would expect, it's going through the motions now. It's got my pipelines to get from source to raw. It's got the pipelines there ready to go in a moment. It's obviously preparing those first ones. Let's refresh impatiently a little more. We're validating, etc., etc. I won't obviously leave this to go through all the steps. It's not the most demo friendly thing. Obviously, there's a lot of interaction kind of happening here, but yeah, you'll see, those pipelines are now running obviously in a controlled way, bootstrapped by the Cumulus control. So kind of refresh here. So I've got a pipeline executor supporting each of those. You'll see it's passed in those dataset IDs like I did in debug mode a little manually. But the point of Cumulus control is that it will handle failures. It will allow us to restart. It gives us a lot more ability and flex over what it is that we're actually doing, to simplify both that kind of journey of that journey from consumer to producer to consumer. So I'll leave that to kind of tick away. I'm sure you kind of get the idea now. We've got all the pipelines, we've got all the metadata we need. We've got a bunch of boilerplate things that are highly dynamic that kind of get us on that journey from left to right. If we wanted to obviously continue that journey, which I was kind of preparing for, obviously depend on time, but if you were so inclined, we could go into Fabric, we could have a Lakehouse, we could mount those Delta tables and serve them through Fabric. We could go through Databricks and we could use those SQL warehouses to serve them out to Power BI and things as well. As you prefer, obviously there's kind of that semantic layer and visualizations and reporting. A little bit out of scope. Obviously, the focus here is just very much that kind of plumbing in the middle to get us to where we need to be. But I'm sure, obviously, it's not too much beyond that kind of leap now. We're getting from our SQL warehouse in Databricks to Power BI to create some visualizations on our bike paraphernalia from our AdventureWorks data in fact and dimension form now. But here's what we could do. Let me wrap up. 2 minutes on the clock with a couple of slides. I'm sure you kind of get the idea. Obviously, there's a lot to kind of take in there, and there's ultimately a lot of kind of investment that's kind of gone into making that possible, as you can kind of appreciate. Let's just do this. So just to finish off, this is not a sales pitch. It's not smoke and mirrors. It's real. It's out there. It's in production. We've got customers using it in anger. So it's open source. I'd love you to use it and things as well, to feedback to me, to let me know how you're getting on with it. There's some case studies on the website that you could work with if you wanted to. And with that, folks, I will say thank you very much for listening. Please don't hesitate to reach out to me. My email address is on the screen there. Also, if you wanted to use that QR code, you're very welcome to put some time in my calendar. Again, I'd love to kind of continue that conversation with you if it's something that you're interested in using as part of your Lakehouse deployment. Thank you.